this section, we're going to be talking about formulas, section 1.5. And formulas basically are going to be equations that involve more than one variable or relates multiple variables together. And sometimes those variables are going to represent different physical quantities or financial applications, or there's lots of different things, physics, chemistry, business applications all over the place here. So couple basic formulas, things that you probably have seen somewhere in the past are things like the Pythagorean theorem, a squared plus b squared equals c squared. We've also have things like a equals p times e to the rt. This is a financial compound interest rate formula. We have things like y equals mx plus b is the slope-intercept form of a line. We have Einstein's formula, E equals mc squared. You've probably seen things like this. We've got one of my favorites is the gravitational force between two objects is force equals the product of their masses, one smaller, one bigger, divided by the distance between them squared, and then multiplied by a constant we call g, the gravitational constant. And so there's multiple formulas. There's formulas for physics, formulas for chemistry. There's PV equals nRT. That's a chemistry formula, and just lots of different things. We have mathematical formulas. And so, but what you want to notice about all these formulas is that they're relating multiple variables. Okay, you've got variables, all over the place. You got 3 of them here, you got 4 of them here, 1, 2, 5 of them there. Well, I guess e is not a variable, so there's 4 of them there. So there's lots of variables in these problems. And so, in most of these formulas, you have a variable that's solved for. So like the slope-intercept form, it's solved for y, but there may be situations where you want to solve for a different variable, like maybe you want to solve for m and get m by itself, or maybe in the gravitational force equation, maybe you want to get the distance solved for because you know all the other values, and so you can do that using the same principles of equality that we use when we solve equations. Okay, let me give you an example, just a quick one here. So y equals mx plus b, and let's say we wanted to solve that for m. Okay, so solving for m just means we want to get the m variable, this guy right here, by itself. Okay, we'll get that by itself. Now, a very key, a key idea for this is to remember that variables are treated exactly the same as numbers. In fact, variables are numbers. They're just numbers that we don't know the value of yet. Okay, but b and x and m and y, they're all just numbers we just don't know. Okay, but they behave the same as numbers. So if I wanted to add the same amount to both sides of an equation, I could add a variable as long as it's the same variable because it's the same number. Okay. Okay, so you have to treat variables like numbers. That's a key part of this this idea here. So let's say I want to solve for m. Well, in solving for a variable, solving for this m here, we want to make sure to get all the other stuff away from it, or zero things out, right? So we want to zero out the b, because that's our constant, and we want to get rid of the x. Well, to get rid of these things, we always do the opposite operation as what's being shown, right? If I had x plus 5 equals 7, I wanted to get rid of the 5, I'd have to do the opposite and subtract the 5. And so we need to do the opposite. So here, I want to get rid of the b first. So I'm going to subtract b from both sides of this equation. Again, if I subtract b from one side, I have to subtract b from the other side. Now, on the right side, they'll zero out. On the left side, however, they don't combine, right? I've got a y and a b, they're two different variables, so I can't combine them together like I would hope to do if they were like, say, both x's or both y's. So here, I gotta leave them separate, y minus b equals mx, okay? So y minus b equals mx. Now, the m is what we're solving for, so I need to get rid of the x. Well, the x is being multiplied here, and so to get rid of that or change it to a 1, I have to divide by the x, right? So I'm going to do that next. Divide by x. If I do that on the right, I must do that on the left. Okay. So now I've divided out the x on both sides. The x's cancel. Oops. On the right. And so then on the left, I'm left with y minus b all over x is equal to m. Again, we're treating the variables like numbers, so we can do all the principles of equality with the variables, just like we would with numbers. The only hard part about this is we just can't simplify anything, right? I can't combine y and b, and I can't combine that with the x because they're all different variables. They're all unlike terms, so there's nothing I can do to simplify, okay? And so we just have this expression as our answer, and it is a valid answer. There, put a cloud around that. That's our answer. It is a bit messy looking, but y minus b over x is a valid answer there, okay? And that is the case for any formula. If you solve for a variable in a formula, you're usually going to get a messy answer, some sort of algebraic expression that involves the other variables in the problem. But that's okay. Messy answers are just as valid as nice numbers, okay?